Hello friends, in this video we are going to discuss the numerical on the digital voltmeters. What is the resolution of a 3.5 digit digital voltmeter for 0 to 1 volt range? And second question is, what is the resolution in 0 to 10 volt range? Okay, so let us first discuss what is the 3.5 digit digital voltmeter, and after that we will move towards the resolution. Okay, so generally the voltmeters, digital voltmeters, are either n digit or n and half digit, and also some are n and 3 by 4 digit, etc. Okay, so here the n digit is nothing but it is the voltmeter which consists of n full digits. N full digits. Now the meaning of n full digits is, okay, all these n digits will vary from 0 to 9, whereas n and half digit, the meaning is it is having n full digit, okay, means these n digits will vary from 0 to 9, okay, and half is nothing but one half digit. One will be the half digit here. One half digit. The meaning of one half digit is this half digit will be either 0 or 1. Okay, so it will be 0 or 1. Okay, so please try to understand. Suppose if the voltmeter is 3.5 digit, the meaning is it is having the 3 full digits and 1 half digit. Okay, so 3.5 digit voltmeter, 3.5 digit voltmeter, yes, is nothing but, as I said, it is having 3 full digits and 1 half digit, okay, so 3 full digits means these 3 digits will be having any value from 0 to 9. Okay, so 3.5 digit voltmeter will specifically a 4 digit voltmeter. Okay, where yes, it will measure, it will be having the digit count from 0000000 to 1999. Okay, so please try to understand this. Okay, 3 full digits meaning is, yes, we are having these 3 digits which are varying from 000 to 999. These are the 3 full digits, and 1 half digit is nothing but this is the, yes, we are having MSB is the half digit, so it is having either 0 or the 1. Okay, so if you check the 3.5 digit voltmeter, it will measure from 0000, 0001, 0002, 0003, like this it will continue till 0999. Okay, and similarly 1000, that is the 1000, 1001, 1002. Okay, and like this it will continue till 1999. So please be careful, these 3 digits are changing from 000 to 999, whereas this digit is changing from 0 to only 1. Okay, so MSB will be having the value either 0 or 1, but whereas the 3 full digits are having the values from 000 to 999. Are you getting the point? Okay, so this is actually the 3.5 digit voltmeter. Now let us discuss what is the resolution. Okay, so here I am writing here, yes, the resolution of a digital meter is determined by the number of full digit used in it. Okay, it is determined by number of full digits, used in it. Please be careful, it is saying only full digits. Okay, and resolution of a n and half digit voltmeter. Okay, resolution of n and half digit digital voltmeter, okay, is given by resolution is equal to 1 upon 10 to the power n. Okay, 1 upon 10 to the power n. So please be careful, this n is nothing but full digits only. Okay, so therefore if you check, okay, this is 1 upon 10 to the power n. Okay, when range is 1 volt. Okay, and in general resolution is equal to maximum voltage, that is the range, divided by total count, that is the 10 to the power n. Okay, so maximum voltage divided by 10 to the power n. So now let us check the question. Okay, so we are having 3.5 digit digital voltmeter. Okay, so 3.5 digit means full digits are only 3. Okay, and for the first case the range is 1. Okay, so resolution will be 1 upon 10 to the power 3. Okay, similarly for the second question the range is 0 to 10 volt. Okay, so maximum voltage is 10 volt. Okay, so we can write resolution for the first case. I am writing resolution is equal to 1 divided by 10 to the power 3. So it is equal to 1 millivolt. Similarly in the second case resolution is equal to 10, range is 0 to 10, so maximum voltage is 10. Okay, divided by 10 to the power n, so it is 10 to the power 3. Okay, so if you check it is equal to 10 millivolt, right? It is equal to 10 millivolt. Are you getting the point? Okay, so this type of question they have asked. Please try to understand the difference between the 3 digit, 3.5 digit, etc. The numerical number 2. Let us read the numerical. The digital voltmeter using the dual slope technique. Okay, so here we are using the dual slope digital voltmeter. Has a reference voltage of 1000 volts. So ER is given and the fixed time as 1000 counts. N1 is given. What is the voltage indicated if the counter reads 762 on the downward slope? So N2 is given. Okay, so first let us note it is given ER is equal to 1000 volt. Okay, next N1 is equal to 1000, N2 is equal to 762. Okay, and our task is to find EI actually. Okay, so as we know in the dual slope integrating type instrument, okay, EI is equal to ER into T2 by T1. We have already derived this expression. Okay, so what is T2? T2 is the discharging time and T1 is the charging time. Okay, so here we are having the waveform like this. This we have already discussed. Okay, dual slope. So here output of the integrator for the time t1 and here it is the output of the integrator for the time t2. So this time is t1 and this time is t2. Okay, so if oscillator frequency is oscillator time is t, if oscillator time or the period is equal to t. Okay, so can we write T1 is nothing but number of count corresponding to T1 or N1, okay, into T, and we can write T2 is equal to N2 into T. Okay, so for oscillator is nothing but it is like a pulse generator. So this type of we are having oscillator, it is generating the pulse like this. Okay, so here we are having the T, that is the time T, period of the oscillator. Okay, so corresponding to each pulse this count will be increased by 1. Okay, so corresponding to N1 count, yes, what will be the time? It is N1 into T. Okay, so we can write EI Therefore we can write EI is equal to ER into, yes, it is a T2 by T1. So we can write it as N2 into T divided by N1 into T. So T will get cancelled. So it is ER into N2 by N1. Okay, ER into, this should be N2 by N1, capital. Okay, N2 by N1. So we can write it is equal to, what is ER? It is a 1000 into what is N2? N2 is given, it is equal to 762. Okay, divided by N1 is again 1000. So we can write it as is equal to 762 volt. Okay, this is the EI, right? So if you check here, the answer will be 762. Okay, final answer is 762, right? So friends, this is about the numerical number 2 on digital voltmeters. The numerical number 3 on digital voltmeters. Let us read the question. The type of analog to digital converter normally used. Okay, so normally is generally used. Okay, in a 3.5 digit multimeter is, and they have given the 4 options: dual slope integrating, voltage to frequency converter type, flash type, successive approximation type. So always keep in mind, okay, out of the all the 4 digital voltmeters, okay, or digital to analog converters, sorry, analog to digital converters, the most popular converter used in the digital meters is nothing but dual slope integrating type digital voltmeter. Okay, so this is the most popularly used because it is having the 2 slopes, and compared to other voltmeters or the digital analog to digital converters, it gives the most accurate results. Okay, so it is a somewhat theoretical question. The numerical number 4 on digital voltmeters. Let us read the numerical. A 3.5 digit 2 volt full scale dual slope digital voltmeter. So here we are having dual slope digital voltmeter, okay, is used to measure a time varying voltage V of t is equal to 1 plus 1 into sine of 100 pi t volt. Then the digital voltmeter indicates, and they have given the 4 options. Okay, so if you check, we are having a dual slope integrating digital voltmeter. Okay, so if you recall the operation of this voltmeter, generally it indicates the analog input voltage signal for a fixed time. Okay, and as such the input voltage signal is generally averaged. Okay, so here the reading of digital voltmeter, reading of digital voltmeter is nothing but average of 1 plus, is nothing but average of 1 plus 1 into sine of 100 pi t. Okay, so what is the average value of any sinusoidal term? If you check average value, and for sinusoidal term, whatever the positive value cycle it is having, the same negative cycle it will be having. So average value is 0. Okay, so average of the DC term, that is the 1. Okay, so it is equal to 1, right? So if you check the reading of the voltmeter, it will be 1 volt. But as this is the 3.5 digit voltmeter, okay, so it will show the reading like 1.000 volt. Okay, so it is like these are the 3 full bits which are showing the 0 value. Okay, and the MSB is the half bit, so it will be either 0 or 1, but as the voltmeter reading is 1 volt, so that's why it will show 1.000 volt. Okay, so if you check the options, correct option is option D. Okay, so friends, this is about the numerical number 4. The numerical number 5 on digital voltmeters. Let us read the numerical. A 4.5 digit digital multimeter has the error specification as 0.2% of reading plus 10 counts if a DC voltage of 100 volt is read on its 200 volt full scale. Okay, the maximum error that can be expressed in the reading is, okay, and they have given the 4 options, right? So if you check here, in this case it is given error is equal to 0.2%, so it is a 0.2 divided by 100 into reading. What is the reading? Reading is 100 plus the 10 counts. So 10 counts is 10 into, yes, the resolution. Okay, what is the resolution? We can write it as 100 divided by 10 to the power 4. Okay, so if you check, it will be equal to 0.3 volt. 0.3 volt, this is the error. Okay, so we can write percent error. We can write percent error. Percent error is equal to, yes, it is plus or minus 0.3 divided by 100 volt. Okay, that is the reading into 100. Okay, so it is a plus or minus 0.3%. 0.3%, right? So correct option is option C. Are you getting the point? Okay, so please try to understand this bit, this point. 10 counts. Okay, so for each count we need to check into 10, that will be your 10 counts. Okay, so like a resolution. Okay, we already discussed resolution is nothing but the voltage divided by the 10 to the power n. Okay, so here n is 4, right? Full bits. So friends, this is about the numerical number 5. The numerical number 6 on the digital voltmeters. Let us read the numerical. A digital voltmeter has 4.5 digit display. Okay, so digit size is 4.5. The 1 volt range can read up to, okay, so maximum this voltmeter can read up to, it is given, they have asked. Okay, so it is a 4.5 digit. Okay, so if you check, it will be having a 1 half digit and remaining 4 are the full digit. Okay, so what is the maximum possible reading? Yes, it will be 1.9999. Are you getting the point? This is the maximum possible reading. Okay, so if you check the options, correct option is option D. Are you getting the point? Okay, so friends, this is about the numerical number 6, because these are the, these 4 are the full bits and this is the half bit. Okay, so 1.9999. Okay, so it will measure from 0.0000 to 1.9999. Okay,